I'm Anil Kumar. With the help of three excellent examples, we'll try to understand number of solutions for a linear system. The question here is, consider the following linear systems. Explain the conditions for one, many, or no solution of the system with following examples. So we have three examples. We'll solve them one by one. In a linear system, you can have one solution provided the lines are not parallel, right? So if you have lines kind of like this, for example, then not parallel, then they will intersect at one point. So we'll get a point here whose value will be some x and y coordinate. So that is the solution for a linear system when the lines are not parallel. If the lines are parallel, in that case, we do not get any solution. For example, we could have a situation where the two lines are parallel, right? So in this case, if we have two lines which are parallel, in that case, we have no point of intersection and we have no solution. Now there could be a condition where the lines could be overlapping, right? So that is to say that one line is coincident over the other, right? So we have coincident line. So in this case, we have infinite solutions. So let's try to solve the given linear systems and figure out how many solutions do we have for each given system. Now let us solve these systems one by one. A. We have a linear system which has two equations. Half of x minus y equals to minus 3 and x minus 2 over 3y equals to minus 2. We'll use the method of elimination here. Now, to use the method of elimination, we need to make coefficients of x or y same. We'll multiply our first equation by 2 to get x with a coefficient of 1 and then solve. So let me number these equations. Let's say this equation is 1 and this equation here is equation 2. So what I will do here is we'll times equation 1 by 2. And then what do we get? We get x minus 2y equals to minus 6. And let's call this equation as equation 3. Now as you can see, in equation 2 and 3, coefficients of x are 1, exactly same. So if I do equation 2 minus equation 3, what do I get? So x minus x is 0. And we are left with minus 2 over 3 y minus of minus 2y equals to minus 2 minus of minus 6. Correct? Let's take common denominator of 3 here, or we can just multiply everything by 3. We could do either one of them. Let's take common denominator. So if I take 3 as a common denominator, I get minus 2y, this is plus, 2 times 3 is 6, y equals to, here we have minus 2 plus 6. And that gives us 4y over 3 equals to 4, right? 4y over 3 equals to 4. Now on the right side, we'll write down the value of y now. So from here, which is 4y over 3 equals to 4, we get y as equals to 4 times 3 over 4, which is indeed equals to 3. So we get y equals to 3 as one of our values. Now we can substitute y equals to 3 in either one of these equations and solve for x. Correct? So let's sub this in equation 1. which is half of x minus y. So I'm substituting 3 here, equals to minus 3. So which gives us half of x equals to minus 3 plus 3, which is indeed 0. So x is equals to 2 times 0, which is again 0, right? So we get x equals to 0 and y equals to minus 3 as our solution. Clear? Now, solution should be written in coordinate points 0, minus 3. Correct? So for this system of equations, we have a solution which is a coordinate point 0, minus 3. Correct? So that is how you could solve it. Now let's take the other two equations. Here is the second equation. We are given 6y equals to 4.5x plus 18 and 4y equals to 3x minus 24. So let's call them our equation number 1 and 2. Now in order to get the same coefficients, what I could do here is multiply equation 1 by 2. So we can times this by 2 and the other one by 3, right? So we get 12y in both the cases. So times first by 2 gives us 12y equals to 9x plus 36. Times the second equation by 3 gives us 12y equals to 3 times 3 as 9x minus 3 times 24 is 72. So we get our equation number 3 and equation number 4. Now see what happens if I do equation 3 minus 4. So if I do equation 3 minus equation 4, what do I get? (12y minus 12y is 0. 9x minus 9x is also 0. And here, when I subtract, I get a number which is positive 808, right? So what I get here is 0 equals to 108, right? Clearly, it is not possible, right? Zero cannot be equal to 108. So that means there is no solution, right? So that means there is no solution. So what do we conclude here? So whenever we get some number, non-zero number equals to 0, then the lines are parallel and the system of linear equation will not have any solution. Is that clear? So this is very important from communication point of view, right? So there is some number and that number cannot be 0. Therefore, we have no solution as a result of this particular function. Is that clear? Perfect. Now let's take the last example. So in example C, we have two equations. 0 equals to minus 7.5x plus 5y minus 20 and 0 equals to 3x minus 2y plus 8. Let's call them our equation number 1 and equation number 2. Now, to get the same coefficients, what we can do is that we can times the first equation by 2 and the second equation by 5. That will make the coefficients of y exactly same, correct? 10. So let's do it. 2 times the first equation, we get 0 equals to minus 15x plus 10y minus 40. And for the second equation, times by 5, we get plus 15x minus 10y, and 8 times 5 is plus 40. So let's call this as our equation number 3 and equation number 4. Now let's do equation 3, take away equation 4. So what happens? So if I take away, I get 0 on the left side. Now minus 15x, rather we should add it, right? Yeah, let's add them. So if I add them, I need to add because plus and minus, right? So if you add, they cancel away. So minus 15x plus 15x, when you add, you get 0. Here also you get plus 0. And minus 40 plus 40 is also 0. So what you really get is 0 equals to 0. Now 0 equals to 0 is always true. Since 0 equals to 0 is always true, we have infinite solutions. So that really means that both the lines are overlapping, correct? That means that the lines are overlapping. So that is how we actually find the number of solutions. So in this case, we will find that the lines are one over the other. They're exactly the same lines. And so we have infinite solutions. So if you get the condition which is 0 over 0, then the system of equations will provide you with infinite solutions. So these lines are called coincident lines. So I hope with these three examples, the concept is absolutely clear. So if the slope is same and also the y-intercept is same, in that case, the lines are coincident and they will have infinite solutions. But if the lines are parallel, then they have no solution. And in case of a parallel, you don't get 0 equals to 0. You get 0 equals to some other number. Perfect. Which cannot be 0. So that is never true. And if the lines are not parallel, in that case, they intersect at one point, as we had in the very first example. I hope that makes sense. Feel free to write your comments and share your views. If you like and subscribe to my videos, then it'd be great. Thanks for watching and all the best.